Let's look at identifying even functions. The definition for something to be an even function is if f of negative x is equal to f of x for every x, then the function is an even function and it has y-axis symmetry. Now, what that means is if we've got f of x equals x squared, let's substitute a negative x in for all of the x's and see what happens. When I take this negative x and I substitute it in here, that would give me negative x being squared. Negative x times negative x is just x squared. So notice that what we ended up with is the same thing as our original function. Since f of negative x is the same as f of x, that means we've got an even function. If we had one that was a little bit bigger, x to the fourth plus x squared plus 1, let's see about whether this one is even or not. When I put negative x in for each of the x's that we have, we get negative x to the fourth plus negative x, then being squared, then plus 1. Now, as we do this arithmetic, anytime you've got an even exponent up there, that's going to make the stuff that you've multiplied together here end up being a positive result. So negative x, when you raise it to the fourth power, going to be x to the fourth. Negative x, if you square it, also an even exponent, that's going to be positive x squared. Then the plus 1 just stayed as it was since there wasn't a variable as part of it. Now, the function that we started off with is the same as the stuff that we got when we put negative x in for all of the x's. But now that's an awful lot of trouble. Let's see if we can't find an easier way to identify if something is an even function or not. For something to be an even function, it's going to have all even exponents when it is completely expanded, when it's been completely multiplied out. So now let's look at some examples about that. The one that we just saw, even exponent, all of the exponents are even, so this is going to be an even function. But now here is one, x to the fourth plus x cubed. Since that 3 is not even, then that makes this function not an even function. Now here's one that's a little bit tricky. X plus 2 is being squared. This is not going to be even because if you were to expand that out, completely multiply it out, the first term, when you square it, makes x squared. These two things multiplied together and then times 2 makes 4x. The last one squared is 4. Notice that that middle term that we get when we multiply these things together and then times 2, that middle term had an odd exponent. It's got an understood 1 for its exponent. Since it has an odd exponent, this is not an even function. For it to be an even function, it has to have all even exponents. Now, if something is an even function, it's going to have y-axis symmetry. What y-axis symmetry means is that every point on the left side of the y-axis has somebody that matches up with them exactly on the right side of the y-axis. They're the same height as each other and the same distance from the y-axis. Here I've drawn f of x is equal to x squared. Now let's look at a couple of points here that are easy for us to identify. The point 1, 1 is right here. If this has y-axis symmetry, there should be a corresponding point on the other side of the y-axis that matches up with it, the same height and the same distance from the y-axis. How far is this point from the y-axis? It's a distance of 1. So if we go one place out to the left, are we back on the graph? Looks like we are. How about this point up here, negative 2, 4? Negative 2, 4 is 2 places from that y-axis. If I go 2 places this way, do I get back on the picture? I do. If you were to cut this picture up the y-axis, you have exactly the same stuff on this side as what you do on that side. That is y-axis symmetry. All even functions have y-axis symmetry. So if a 0.11 is part of the picture, it must have negative 1, 1 on the picture as well. If negative 2, 4 is on the picture, it must have positive 2, 4 on the picture as well if it has y-axis symmetry. All functions that have y-axis symmetry are even, and all even functions have y-axis symmetry. What about an odd function? The official definition for an odd function is if f of negative x equals negative f of x for each value of x, then the function is odd, and it's going to have what's called origin symmetry. The easiest example of something that's odd would be just x cubed for me. If we take negative x and we put it in for this x, negative x times negative x times negative x, that's an odd number of negative factors, so that's going to give us a negative result. It's negative x cubed that we ended up with. Now notice that this negative x cubed that we've ended up with, it's completely opposite of the x cubed that we started off with. Since they are completely opposite things, this is an odd function. Look at a harder one. X to the fifth minus x cubed. When you put negative x in for all of the x's, you would have negative x to the fifth minus negative x cubed. Now, since we have these odd exponents, negative x to the fifth would be negative x to the fifth. When I do negative x cubed, that's negative x cubed, but the negative that's in the middle, two negatives, made a positive result. Look at what we ended up with here. All of this stuff is completely opposite of what we started off with. This was a positive x to the fifth. Here is a negative x to the fifth. This was a negative x cubed. Here is a positive x cubed. So this is an odd function. When they are completely opposite, that makes them odd functions. I see here that to make them turn into opposites, it looks like I need odd exponents. So when we try to find an easier way to do this, odd functions having all odd exponents will need to be part of it. Unfortunately, there's a little bit more to it with an odd function. Let's look at the next example here, x cubed plus 1. If you put negative x in for all of the x's, when you take negative x and cube it, you get negative x cubed. But the plus 1 stayed as a plus 1. While this part is opposite of what we started off with, the back is not. The back part was a positive 1 here, and it's a positive 1 there. So this one is not odd. Having that constant value at the back messed things up for us. So an easier way for us to determine if we've got an odd function or not, first, they have to have all odd exponents, but it's also going to have no constant value at the back. Now, one exception to this rule is with circle equations. They have even exponents, but they are still something that has origin symmetry. So now for an odd function, for us to identify an odd function, we're looking for all odd exponents and no constant. Here, x to the seventh plus x to the fifth minus x cubed, all odd exponents, no constant, it's good. That makes it an odd function. X to the fifth plus x to the fourth, there's an even exponent. 4 is not odd, so this is not an odd function. What is it that causes this one to not be an odd function? That's right. It's got all odd exponents, and it's good so far, but that constant value at the back messes it up. So it's not an odd function. Now, one last thing for us to keep in mind, O for origin and O for odd. If you've got an odd function, it's going to have origin symmetry. So those O's go together. What origin symmetry means is if you have a point 1, 3 on the picture, you would also have a point -1, -3 as well. Odd functions have all odd exponents with no constant value. Odd functions have origin symmetry. Anything with origin symmetry has to be an odd function. Now let's take a look at an example of where you'll see that in your homework. Here we're given a picture and we're given an equation for us to determine if this has y-axis symmetry or not, and if it's even, odd, or neither. Now, as I look at this, when I look at the picture, I see that it's got the same stuff on the left side of the picture as it does on the right side of the picture. So it's going to have y-axis symmetry. But I would encourage you to look at those exponents. Even exponents in both places. So this is an even function. What type of symmetry goes with an even function? Y-axis symmetry goes with an even function. So now if you see those even exponents, it's going to have y-axis symmetry, and anything with y-axis symmetry is an even function. Even functions have y-axis symmetry and all even exponents. How about another? When we look at this one, we are told the equation. It says x to the 11th minus x to the 5th. Those are odd exponents. Do I have a constant value there? I don't. All odd exponents makes an odd function. All odd exponents make an odd function. Since it's an odd function, O for odd and O for origin, the O's go together. Odd functions have origin symmetry. Even functions have all even exponents with y-axis symmetry. Odd functions have all odd exponents and they have origin symmetry. Can't be a constant when you're talking about odd functions. There can with even functions.